Hi, my name is Georgi Pavlov. I'm enterprise architect at Dell Technologies. My area of responsibility is global online digital lifecycle experiences. With this session, I would like to walk you through our journey in Dell.com towards EDA, and hopefully you walk out with an understanding of what we see beneficial in EDA, how we have put it to good use, and some challenges that we've met along the way, which hopefully is going to help you also in your own journey. Now, in our online experience channels like Dell.com, we have designed certain customer experience journey. This is a journey that comes at a scale, meaning we have billions of dollars coming from these channels, millions of transactions that are happening on a yearly basis. There is thousands of people working to make this happen, and hundreds of systems making this really materializing this and making it happen. So it's a huge system and huge enterprise, and it also has some history. These are all points that we'll be coming back to. Hence, it's important to set with context of this conversation in principle. With that said, let's walk through a simplistic, view of the customer journey that we offer to our customers online. So you go through certain stages. Starting perhaps with discovery of opportunities. When you go to Dell.com as regular individual customer or maybe a business customer, and you start exploring there. Eventually, you find something that catches the eye, and you go to configuring this as an offer for you to buy, either as a self-service or using self-representative services for that. And eventually you order or update maybe something that you already have existing, but you want to expand. Then we get the order, things turn into onto Dell side. We get the order and we start all the manufacturing, logistics, and finally we deliver the order, the product that you have ordered to your door or in your data center or whatnot, depending on what you have bought. Despite that it looks like this is something on Dell's end, it's still part of the customer journey because we don't keep you in the dark. We keep you constantly engaged to the extent that you want to give you the full transparency and manage your expectations toward SLAs and where we are with the process, what to expect and whatnot. So eventually when things settle and you already have your product, you start happily using it, which means operations of these products, either with our facilities or with your own, and our support services. And finally, we give you some billing insight and opportunities for financial optimization, which eventually may lead you again to the discovery stage where you try to optimize your portfolio or expand to new opportunities that we can offer you. Hence that this is kind of a continuous cycle and a continuous engagement that we are trying to loop you in for your benefit. So what kind of customers do we serve in this way? Well, basically all the possible customer segments. We have individual consumers, we have small and medium businesses, we have large enterprise businesses. Dell's portfolio is pretty large, from hardware to composite offers through subscriptions and whatnot and services. And you have different financial options to enable the best experience and value for you, meaning they could be capital expenses, or they could be operational expenses, and there are different variants there, like leasing and subscriptions and whatnot. Now this is the journey and the customer journey and the overall context into which we're going to be talking. And now let's find out where do events find their way into this setting. Now, by no means this is some extensive list or something. It's just here to make the points that are quite abundant and pervasive almost everywhere. We have them, for example, around discovery and optimization when we do some analytics, and based on that, some recommendations to you, what would suit you best for your needs. We use them extensively for decoupling the master data systems from our front-end systems so that we can realize up and running no matter what front channel experience for you. We quite extensively use them as well for process orchestration, giving you status for where you are, for example, with your order and whatnot, and also telemetry and so forth. So suffice to say that you can find them pretty much everywhere. Now, that would be an endless talk if we had to talk for each and every segment and use of the events and event-driven architecture in those customer experience journeys. So we're going to focus this a little bit in the next slides. So our customer journey started somewhere around REST APIs were very popular. So no wonder that we have built distributed microservices architecture around heavily around REST APIs. What is really characteristic to our architecture, that it's always mattered characteristics like availability, fault tolerance, performance, scalability, things like this primarily. And coming from that perspective of trying to maximize this, really, we made a few changes. Namely, we introduced a more reactive pattern of pushing data, master data towards the experiences, rather than them trying to pull it all the time, wherever we can. We did this by introducing message queues and event brokers, and now you can see that there is a lot more interaction paths between the services in the experiences and the services from the master systems in the platform. So we have diminished these interactions to some highly transactional scenarios only, and some data lifecycle related things where we need to replicate data between the master system and the experience systems to make it redundant and highly available for us. And in this setting, we have a little bit different integration layers now, and a lot new opportunities. Now, if we look at this again from really integration perspective, here we have the following layers. On experience context level, we have integration layer with the MFEs that could be composed via some MFE composition protocol into larger MFEs to produce sort of portals and composite MFEs or whatnot. We have the experience service microservices integration layer, where you can use the REST APIs to integrate either in B2B scenarios or internally, where basically what you need to talk about is protocol and data when you want to integrate. We have the aggregate experience state in our own databases in the experiences. I put this down as private, meaning we don't use really the database interfaces to integrate. However, the data itself, it's not private. It's made available obviously through the APIs and through the event brokers, which is essential. And coming down the stack, we have the event brokers themselves that actually expose the data as the integration layer, and the schema being really your API that you need to integrate with. And that's going to be hugely important, as we're going to emphasize pretty soon, because it really reduces the things that we need to talk about. And hence, it improves really the discussions and the time to market as well. Other than that, we're using event brokers really for integration between the contexts, between the context and the domains in the domain services in the digital commerce platform below. That is our master system of record. The domain services themselves are using it among them and whatnot. So it's pervasive and in multiple integration points. So let me put this from this a little bit abstract form into something more tangible, like a more concrete case. It's again, I must make the disclaimer that what I'm going to show is kind of very simplified and not 100% accurate, but it's sufficient to make the point. So we had this case where we had to realize some sort of post-sale engagement with the customers, and we needed to show them their options for their upgrade options for the offers that they have already bought. So to do that, we needed to fetch information from several backend systems. from the REST APIs, and do this in particular order because this is the type of correlation of data that was available. Now this had several problems, starting from the possibilities for the systems to fail and fail the overall stability of the system. The performance itself, because you had to go through the overhead of calling several services and then aggregating this data and whatnot, and many others. So the way we changed that was to introduce event brokers as a middle integration layer and turn the whole pattern from pulling data to pushing data towards us. And that hugely improved everything and simplified the case for us. By simply decoupling the backend systems, we relieve them from the burden of direct internet traffic loads to them, and also it makes it easier for us because we already own the data when we need it. It's got the shortest path, so we don't need to travel to take it. So the performance greatly improved. We benefited seriously from this simple, change of the thinking and the paradigm. Now, I'm coming to something that I already mentioned several times, but it's really important for to make this point. And it is EDA as the ultimate tool to microservices integration. This is one of the things that is often overlooked because it's not so obvious. You need the data points to make it visible. It's not like you make some analytic query and you see directly the results or something. No, you can see this by the reduced amount of people and effort that you put on those midnight calls when things start crashing, and recovering from them, just because you have made your system a lot more resilient by introducing this decoupling the way it should be in principle for microservices, because we know that in distributed system it's really good that we have them highly autonomous and highly decoupled and that they can operate on their own. But in practice, it's really hard to make this happen when we have direct dependencies to other systems, and you always have this case. And that's where EDA comes really, really handy for us. So the integration blueprint to make this happen is the following. If we look at the right-hand side, you typically have two types of data producers that make data available to an EDA broker system. One type of the users would be the upper one. That would be those that you can't normally touch or you don't want to touch because of various reasons. Could be legacy system, could be because it's a third-party system that you don't really know the internals or you're not authorized really to make changes to it, whatever. In these cases, what you can do is normally just schedule regular pool of the data, and there is not much more that you can do about this. There is, however, other types of systems that are normally new systems, or at least those that you can touch, and that's where you will want to introduce a consistent way of pushing data directly from your databases directly into the event brokers and their topics. In these systems you would want to follow the outbox pattern, which has the nice benefit to keep things really separated and the developers blissfully unaware of what you're going to do with these transactions that they are committing. Suffices that they're sending their business transaction, making sure that they make one more record encapsulated in this same transaction, and that's all. After that, change data capture mechanism will take it over for you and automatically make this transaction into a data record into the broker topic, and that's all. You will want to introduce this because consistency really matters, especially in enterprise. When we're talking about commerce systems and whatnot, it's more likely that consistency is going to be a topic rather than not. And this is why we make a lot of effort to make sure that data is consistent all the way through, coming from the business transaction to the topic and then to our consumers. Speaking of the consumers, yeah, what's important about them is that you make sure that you decouple the mechanisms for consuming the data and what you do with the data after that. So in this example, and it's quite possible an abundant example, you would have a REST API, maybe a BFF that serves data to some front end, micro front end. You would have this REST API only reading this data, whereas you have the event consumer being maybe even a separate process, some serverless process or something like that, that is pushing the data. It's important to decouple the two scenarios, consuming the data and making it available. Again, from resiliency perspective. We're going to come back to this just in a second. And speaking of resilience, this is where we are. What we get from this pattern? Well, if we have to examine it, there is three things that you immediately observe. First of all, the complexity is significantly higher than in, let's say, a pure RESTful landscape. Then the costs, because of this more complex landscape that you have to build up, are also higher because you have much more moving parts. However, the organizational synchronization overhead between the different departments that need to come into sync how to consume the data and what to do with it is lower than in the RESTful scenario case, because in this case, we need primarily to talk about the data in its schema, not how we get it. How we get it is the protocol, how we access it, and it's clear. It's going to be the event broker protocol, and that may look small, but in fact, it makes for a big case about data democratization, because if you have it this way, you can have a lot of use cases that you have not even envisioned. You have your consumers' hands and tides to get creative, and not necessarily even whoop you in these details. They're just going to create new use cases and come up with new ideas on the fly. Now, let's continue a little bit the investigation and see why we claim that this is resilience by design. What could possibly go wrong in this setting? Well, without going into every single detail, let's look at it simply, and we're going to see that if we scratch whichever component in the provisioning part of the scenario, that the producer of the data, the broker itself, the consumer of the data that is going to make it available to the microservice, scratch any of that, and in this setting, you're still going to be able to serve your customers. Now, given the disclaimer that you can live with a little bit of stale data probably and things like this, but in the majority of cases that would be sufficient, and hence that's a huge benefit for systems that require availability as top priority. Really the risk scope where the splash damage is, that's really only the microservice and the database that caches the master data state. That's all. Obviously, whichever of these fails, you're not going to be able to serve your customers. However, compared to the other case where you directly depend on other systems, this is a huge improvement again, because in the other case, the risk scope is really the entire system. Whichever part of it fails, you're done. You cannot serve your customers. Now, I've talked about how great EDA is in providing, integration opportunities in the way they should be for microservices. Really, the resilience that it provides as a benefit out of it. The improved synchronization between the people and whatnot, the reduced time to market based on that, all the good stuff. I'm sure that actually we're probably going to hear a lot of other good use cases for EDA on this summit event. I myself am looking forward to look at these presentations and learn more about it. We ourselves have a lot of them, like top of my mind, telemetry and analytics and whatnot, and audit logging and stuff like this. So great. But again, what I wanted to emphasize was really the benefits of using it as an integration tool, and that because it's maybe not the most obvious use case and benefit of them all. However, we have to also mention things that you need to consider. I don't necessarily put this as bad things or things that are showstoppers. These are just things that you need to consider. Because here we are trading certain problems with other problems. So you have to decide which problems you want. Now, some of the things that you need to consider overall is the increased complexity of the system. Hands down, EDA is still pretty complex to realize. Then you have to consider that you need also to raise some capacity building, meaning not only hardware, but which is more important probably to invest in your people to improve their skills in EDA, because there's a lot of problems that are really not trivial. It's just much easier to deal with problems in the REST world rather than this asynchronous reactive world. There is something that's rarely mentioned, but it happens, and that's what I call my precious data syndrome. Microservices teaches us this share nothing philosophy for good. There is a good reason for that. And people start to tend to think about the data, the redundant data that the microservice retains and makes available to the outside world. That's something that they should really control. And they should control it, no argument about it. The problem is that we have to start thinking that we don't necessarily need to control the way this is accessed when we deal with things with EDA that take this out of the table. And that is a good thing. That's one less thing that we need to talk about and concern us. It actually opens up for more creative conversations and more focus on smaller things and significantly improved cognitive load on everybody at the end of the day. But nevertheless, that's something that people tend to adhere to. So you need to explain the benefits of not clinging to the access to the data as something that they should never let go. Another thing to think about, these are more technical stuff, like event ordering, distributed transactions, and whatnot. These are not trivial again. Something that can be really nasty is whenever you start distributing data in your system, you reach to a point that this data is going to start to deviate from its master source. So first you need to decide where is your source, because EDA nowadays, the contemporary solutions, they also provide you with the opportunity that they become the source, but that's not always possible and that's not always feasible. So you have to figure out where do you want this source, and you have to come up with remedy solutions when things start to deviate. And that's not always easy, because if it was only databases, you just run a script, fix the data, and you're done. But here you have a distributed immutable lock. And not only this, but it's not only the latest state, it contains basically all the state that you have told it to maintain. It could be, well, everything from the dawn of time. And that's a huge amount of data. So it brings its own type of challenges. There are other, like, considering the data change frequencies when you do aggregations and whatnot. This list can go on quite a lot. But the bottom line is that it's a complex topic, so you make sure to deep dive well into it before you jump to conclusions and make your judgment on how it works and things like this. And we have to put on the table, the economy part of it, because it's at the end of the day, somebody has to pay the bills. You get questions like, well, is the transition from distributed REST monolith really worthy in terms of investment? Okay, statistically, you can live with the high availability that you currently have, so why bother with this huge investment and complexity? How really important are availability and performance? I mentioned several times that for us it's critical, and this is why we made this approach, but you have to really critically think about, do you really need it? you have too many moving parts which come with licenses and stuff, so it could be prohibitively high cost at the end of the day, and whatnot. So to conclude, the key takeaway for you here is that EDA is great. I mean, for some certain use cases, it makes a great point. Particularly, I wanted to make the point that it's a great tool to do integration between distributed systems the way that it's meant to be in a microservices architecture. So definitely something to look into. Just keep in mind that it's not going to come without a price, and you have to be well prepared to deep dive into what exactly you need to pay for it. It's okay. You just have to have a plan and meet the challenges. And something learned from the trenches. It's going to take time. It's going to take time, and consider that this is a journey. It's not like a 3 months project and you are done with it. It's a journey, because every day you discover new opportunities, and that's great because it's really boosted the creativity and the business opportunities based on that. And one advice from me to conclude: if you struggle to build the use case for the integration benefits from EDA, just put on the table who gets the 3 AM outage call, guys. That should give you some leverage, I think. Thank you very much.